Good morning, class. Today we're going to start section 4.3. And our topic is right triangle trigonometry. So we've already been dealing with right triangle trig all along. Recall that with our unit circle, so with a radius of 1, so let's say this is pi over 3, the measure of this central angle is equal to the measure of this intercepted arc. Well, what we did was we dropped an altitude here. We call that y and that x. Then the sine of pi over 3, which is the sine of 60 degrees, is equal to y divided by 1, or just y. The cosine of pi over 3, cosine is adjacent divided by hypotenuse, so that's the same as the cosine of 60 degrees, and that gives us x over 1, which is just x. Now we're going to try to extend this to right triangles in general. So let's say we have a right triangle. Typically the way we're going to label this, let's call this angle here, this acute angle here, theta. Typically the way we label this is we'll go A, B, C. So the angle measures are capital letters. The side that's opposite angle A will be lowercase a. The side that's opposite angle B is lowercase b. And the side that's opposite angle C is lowercase c. Then from what we know from before, we know that the sine of theta is the side opposite angle theta divided by the hypotenuse. So that's A over C. So in this case, our hypotenuse is not necessarily 1. Cosine of theta is the side adjacent to angle theta, so that's B divided by the hypotenuse, C. And our tangent of angle theta is opposite divided by adjacent, so that's A over B. Our reciprocal properties, the reciprocal of sine is cosecant, so the cosecant of angle theta is C divided by A. The secant of angle theta is the reciprocal here, so that's C divided by B, so that would be hypotenuse over adjacent. And the cotangent of angle theta, so tangent is opposite over adjacent, so cotangent would be adjacent divided by opposite. Then of course, we know about our Pythagorean theorem. Which says in a right triangle, the sum of the square of the two legs is equal to the square of the hypotenuse. So in this case, our legs are A and B, our hypotenuse is C. So that's where the A squared plus B squared plus equals C squared comes from. So it's leg squared plus leg squared is equal to hypotenuse squared. Now what we notice here is that this triangle has 6 pieces to it. It's going to have 3 sides and 3 angles. Within those, within the angles, or acute angles, we are able to write our 6 trig functions. Okay. So if we have all 3 of our sides, we would be able to find all 6 of our trig functions for that particular angle. So let's take a look at an example. So here we have a right triangle, And there's A, B, C. We call that angle theta. So let's say A is equal to 5 and B is equal to 12. Okay, so we want to know what the sine, cosine, tangent, cosecant, secant, and cotangent are of these angles. Well, we can use the Pythagorean theorem to find the length of sides C. So leg squared plus leg squared is equal to the square of the hypotenuse. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. So C is the square root of 169, which is 13. Now that we have all three sides of our triangle, we can find all 6 of our trigonometric functions at angle theta. So sine of angle theta is opposite divided by hypotenuse, 5 divided by 13. Cosecant of angle theta will be hypotenuse divided by opposite, or the reciprocal of sine. So that's 13 divided by 5. Cosine of angle theta is adjacent side to theta divided by hypotenuse. So that's 12 over 13. And the secant, which is of theta, which is the reciprocal of cosine, would be 13 divided by 12. Our tangent of angle theta is opposite divided by adjacent. So that's 5 divided by 12. And our cotangent of angle theta is the reciprocal of tangent. So that's going to be adjacent divided by opposite, which is 12 divided by 5. Okay, so let's try another one. So our next example is our right triangle. Here's our theta. Here's A, B, and C. And A is equal 1. Let's say C is equal 3. So the first thing we need to do is solve for B. So leg squared plus leg squared is equal to hypotenuse squared. So here B squared plus 1 squared is equal to our hypotenuse squared, which is 3. B squared plus 1 is equal to 9. B squared is equal to 8. So B is equal to the square root of 8. And we remember that 8 has a perfect square factor of 4. So B is the square root of 4 times the square root of 2. So that's 2 square root of 2. So now when we generate our 6 trigonometric functions, we will have to look out for the fact that you may have a radical in the denominator. So sine of theta would be opposite divided by hypotenuse, 1 divided by 3. Cosine of theta, cosecant is the reciprocal, so that'll be 3 divided by 1, which is 3. Cosine of theta is adjacent divided by hypotenuse, so that would be 2 square root of 2 divided by 3. Secant of theta is hypotenuse divided by adjacent, so that's 3 divided by 2 root 2. So in this case, we do run into the issue where we have a radical in our denominator. So we know how to take care of that. We multiply by a special form of 1, root 2 over root 2. So on top, you get 3 times root 2. We're going to get 3 root 2. On the bottom, we get root 2 times root 2, which is 2. 2 times 2 is 4. So our cosecant of theta is 3 root 2 over 4. Our tangent of theta is opposite divided by adjacent. So that's 1 divided by 2 root 2. And our same issue here. So we multiply by root 2 over root 2, special form of 1. Guarantees that we're not changing the value of this expression. So 1 times root 2 is root 2. And again, root 2 times root 2 is 2. 2 times 2 is 4. Our cotangent of theta is adjacent divided by hypotenuse. So that would be 2 root 2 divided by 1, which is just 2 root 2. Okay. Now, when we constructed our unit circle, the angle measures that we chose were either generated from the special right triangle of 45, 45, 90, or from the 30, 60, 90 special right triangle. In both of those instances, we were using the unit circle or a radius of 1. So we know that the cosine of 45 or cosine of pi over 4 is square root of 2 over 2. We know that the sine of pi over 6 is 1/2. So do those angle measures hold in any 45, 45 special right triangle or any 30, 60, 90? So let's test that out. So let's say we have a 45, 45, 90 right triangle. So it's an isosceles right triangle. And let's say we have our legs equal, let's go 5. Okay, so we can use our Pythagorean theorem to find the length of our hypotenuse. So c squared is equal to 5 squared plus 5 squared. C squared is equal to 25 plus 25. C squared is equal to 50. Or c is equal to the square root of 50. So the perfect square factor in 50 is 25. So 50 is 25 times 2. So c is actually the square root of 25 times the square root of 2, which is 5 square root of 2. Okay, so the sine of 45 degrees is going to be opposite divided by hypotenuse. So that's going to be 5 divided by 5 square root of 2. So 5 divided by 5 is 1, so that's 1 over square root of 2. And when we rationalize our denominator, we're going to get root 2 over 2, which is exactly what we got on the unit circle. Tangent of 45 degrees is opposite divided by adjacent, which is 5 over 5, so that is 1. And cosine is going to be the same thing as sine there. So it seems it really doesn't matter what size the isosceles right triangle is when we find the sine, cosine, and tangent of the 45-degree angles. It's the exact same that we got on the unit circle. So keep that thought in mind as we go through a couple more examples. So let's take a look then at the case of the 30, 60, 90. 30, 60, 90. So with the 30, 60, 90, we generated that triangle from an an equilateral triangle. And we used the side length of 1 because we were using the unit circle. So let's say, though, that we have this equilateral triangle and all 3 sides are 8. So that means that all 3 of our angles are 60 degrees. Okay. And when we draw an altitude, we know that these 2 triangles are congruent by hypotenuse and leg. So if the hypotenuse and leg of one triangle is congruent, and a right triangle is congruent to the hypotenuse and leg of the other, 2 triangles are congruent. So if this was 8, that means that this side is 4 and that side is 4. Okay? So this angle here, because we split it, is 30 degrees. This angle is 60 degrees. All right, so we can use the Pythagorean theorem again to find this missing leg length. So we're going to call that y. And we'll use the triangle to the right here. So leg squared plus leg squared is equal to hypotenuse squared. So y squared plus 4 squared is equal to 8 squared. Y squared plus 16 is equal to 64. We subtract 16, we get y squared is equal to 48. Okay. Now, what we know from our unit circle is that the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. So we're trying to see if that still holds with this 30, 60, 90 triangle. So y is the square root of 48. And our perfect square factor, our largest perfect square factor in 48 is 16. 48 is 16 times 3. So the square root of 48 is the same thing as the square root of 16 times the square root of 3. So we're going to get 4 root 3. Okay. So now our triangle looks like this. Okay, so our hypotenuse is 8. Our shorter leg is 4. Our longer leg is 4 root 3. Here's a 60-degree angle there, and a 30-degree angle there. So, again, from the unit circle, we said cosine of 60 degrees is 1/2, sine of 60 degrees is root 3 over 2. So let's try that. So here's our 60-degree angle. Cosine of 60 degrees is adjacent divided by hypotenuse. So that's going to be 4 divided by 8, which is 1/2. Our sine of 60 degrees is opposite divided by hypotenuse. So that's going to be 4 root 3 over 8. If we simplify this, 4 goes into itself once, goes into 8 2 times, so our answer is root 3 over 2. So not only do these angle measures apply on a unit circle, they will apply with any right triangle. Now we're going to take a look at the trigonometric functions, and specifically the two positive acute angles in a right triangle. So here we have a right triangle, the right angle. So if this angle is theta, what's the measure of this angle right here? Well, we know that the sum of the interior angles of any triangle is 180 degrees. So this angle here is 90 degrees, which means that the remaining two angles, the sum of those two angles, must equal 90 degrees, because these two angles together plus this 90 will give us the 180. So this angle here, we know that it's 90 minus theta. So whatever theta is, this angle is going to be 90 minus theta. These two angles are complements of each other. So remember that two positive angles are complements if their sum is 90 degrees or pi over 2. So because of the fact that these two angles are complements, we're going to define some co-function identities. So co really stands for the complements. So I'll give you an example here. So let's say this is A, that's B, and that's C. Okay. This angle theta, sine of angle theta, is equal to opposite A divided by C. Okay. But if we were to look at this angle from the perspective of the angle up top here, whose measure is 90 degrees minus theta, then the cosine of the 90 degrees minus theta angle, well, the cosine is adjacent divided by hypotenuse. Now our perspective has changed. If we're looking at this angle here, the side that's adjacent to the 90 degree minus theta angle is A. So that's A over C. So what we see here is that you have two trig functions whose value is A over C. And I know you guys all remember that transitive property you studied so much in geometry. If both of these are equal to A over C, then they are equal to each other. So sine of theta is equal to the cosine of 90 degrees minus theta. Okay, so these two functions are considered cofunctions. They're cofunctions. If f of theta is equal to g of 90 degrees minus theta, and g of theta is f of 90 degrees minus theta, then f and g are cofunctions. They're cofunctions. So sine and cosine are cofunctions. Secant and cosecant are cofunctions. Tangent and cotangent are cofunctions. So the way that looks is we know that sine of theta is cosine of 90 degrees minus theta, and we could replace the 90 degrees with the pi over 2. Cosine of theta is the sine of 90 degrees minus theta. Tangent of theta is equal to the cotangent of 90 degrees minus theta. And cotangent of theta is the tangent of 90 degrees minus theta. Secant of theta is the cosecant of 90 degrees minus theta. And cosecant of theta is the secant of 90 degrees minus theta. So these are cofunctions of each other. Okay. So an example from your homework would be find a cofunction with the same value as a given expression. So find a cofunction. So let's say we had sine of 72 degrees. What would a cofunction value be? Well, cosine is the cofunction of sine. So sine of 72 degrees is equal to the cosine of 90 degrees minus 72 degrees, which is the cosine of 18 degrees. Okay? So let's verify that. Let's make sure that that's true. All right? So we have, let's see. All right. Oops. All right, so we said the sine of 72 degrees. Oops, I'm on radians. Let me go to degrees. All right. Nope, that's not it. Let's try it one more time. All right, stop it. Okay, let's change that to degree. It's on degrees. So we're going to say the sine of 72 degrees, oops, and that is equal to 0.95105. So we're saying the sine of 72 degrees is equal to the cosine of 90 minus 72 degrees. So let's go cosine of 90 minus 72 degrees and what do you know? It's equal to the exact same thing. You could do the same thing for secant with cosecant and tangent with cotangent. Okay, so now that we've seen that that's true, we need to be able to work with these functions in degrees and in radians. So let's take a look at the next example. What's the cofunction to cosecant of pi over 3? So in this example, we're not going to be dealing with degrees. So the cosecant, the cofunction to the cosecant of pi over 3 would be the secant of pi over 2 minus pi over 3. So it's not 90 minus pi over 3. We have to use pi over 2. So we're going to need a common denominator. And I believe our common denominator here, LCD, is 6. So then that's going to be secant of, so here we will have to multiply by 3 over 3. So that'll be 3 pi over 6 minus 2 over 2, 2 pi over 6. So that gives us secant, 3 pi over 6 minus 2 pi over 6 is pi over 6. So what we're saying is that the secant of pi over 6 is equal to the cosecant of pi over 3. Okay? Your homework is on your sheet there, and I will see you tomorrow.